and today we're going to talk about how RISC-V is being used in the autonomous vehicles, both for ADAS and autonomous driving. My name is Itai Yarom, and I'm responsible for sales and marketing at MIPS. And we're going to touch about what RISC-V contribute for the automotive industry, what is the MIPS solution, how it's find together or expanded the RISC-V to fit to the automotive industry, and we look about how we find an example of a solution that's going to be rolled out in the market in a couple of years. So last year we announced that MIPS is going to support RISC-V instruction set. This was for some people a surprising announcement because for a long time MIPS has its own instruction set. But the reason we chose to support the RISC-V ecosystem and to join it and be part of it is we saw an opportunity to take our knowledge and our experience in bringing our technology to a microarchitecture to develop multi-cluster, multi-core, multi-threading kind of solution with tens of billions of chips already deployed in the market, and to leverage this in the RISC-V ecosystem to accelerate the adoption and to take advantage of the growing ecosystem of RISC-V, and actually to reduce the risk for new software development. And together, both of these solutions bring a know-how and silicon-proven architecture together with a low risk and software adoption. And when we're looking on the automotive industry, and tomorrow we're going to have a talk about the data center and how RISC-V is operating there. But when we're looking on the automotive industry, MIPS is today being used by 70% of the ADAS system, and also by 70+% of the growing level 3 and level 4 kind of system. And we described a little bit about how the industry is moving from a small aftermarket level 1, level 2 kind of solution to adoption of level 2, level 5. I'm thinking today is 80% of all new vehicles come with some kind of ADAS solution, to go into more premium solution with part of the road you can have hands-on and even some kind mind off of driving the road, and the car can take on the part of the highway and drive the car itself. And when we're looking on this kind of solution, we see also a transition from a closed system that all the software being developed by one or two vendors to a more open system that many software are being run on the same silicon. And this transition also take advantage of the RISC-V ability to support different types of software and have the open ISA to support that. So to address the transition, we're taking our solution that is already have 17% of the ADAS market to transition to RISC-V to adopt the new generation and the new direction that can support open systems that run in multiple software and multiple applications on top of the different ADAS kind of application. Last year on CES, we announced about Mobileye plan to use the MIPS EvoCore P87 license in their coming IQ7 solution. This solution will be deployed for level 3, level 4, and even robotaxi kind of solution, and enable a low-cost one solution for scaling down for level 2 to level 5 kind of application, depending on the configuration of the software stack. And when we look on the application, how it fitted up, so we're talking about getting to a market that already have 70% market share owned by Mobileye, with most of all car manufacturers using a Mobileye solution and also developing additional capabilities on top of it. And what we provide is the ability to have the multi-cluster and what we call shared memory between the CPU and the AI accelerator, that you can move data seamlessly to the right engine to execute it. So this is enable a significant boost in performance compared to alternative methods that use software-based instruction to move the data to the right AI accelerator. And in this complex chip, we have multiple CPUs, and we have multiple types of AIs, and for each type of AIs, we have multiple entities of them. And we also take advantage of the RISC-V ecosystem in the Mobileye Evenance, as well as the availability of the IQ6 and follow with IQ7 RISC-V SDK development for the major OEMs. So you can have a development platform that you can use it to develop those kind of systems. And even today, if you want to experience just for yourself, you can use with a virtual platform for partner like Imperas that provide this kind of solution. So if we look in more detail about this CPU, then this is out of order 16-stage pipeline CPU that support real-time operating system, but also complex operating system like Linux with full MMU and virtualization. It provides wide execution pipeline with ability to support both optimization and things like that around memory subsystem and so forth. So we are taking the RISC-V instruction set as a base and to support it, and we are having some specific user-defined instruction that are covering some of the gaps we have today in the RISC-V for prefetching, for memory snooping, doing all this kind of optimization to have a more efficient data, a multi-cluster kind of data movement. But this is not something we want to keep for ourselves. This is something we want to be, we will be part of the RISC-V instruction set going forward. So this is we believe our expertise is how to implement it in the microarchitecture and really build a scalable solution. And when we look about this type of performance, so this is two examples of the leading out-of-order kind of CPUs. So if we compare the top RISC-V CPUs and also general kind of CPUs in the ecosystem, by combining both out of order with two-thread, we are getting a better performance and better performance efficiency per area. And this is with the high-end kind of CPUs. And this is just one example of a benchmark that looking in some of the subsystem of the memory and things like that, but a more complex and user kind of software will see we see that our customer have even a larger benefit when running this kind of application. Another thing we're looking at, we talk a little bit about memory, it's not just about pure performance, ALU performance, it's also about memory movement. And this is another example about how multi-threading and how efficiency the coherent manager is moving data between the CPUs. So even in the case of a single CPU with a single memory pipeline connection compared to competition with two CPU system, so we have two virtual CPUs, they have two physical CPUs. So even in this example, we have a better bandwidth because of the way we build the memory infrastructure for the chip. And then when you scale it up and you look in a system, and this is just an example of silicon that's going to be out. They're going to be silicon for automotive, they're going to be also silicon for data center. This is the one example of silicon going to be out later on next year. And you can see the ability to scale and to optimize both the performance and the running between the CPU and the memory subsystem. So a few more slides before we wrapping up. So we have experience coming from MIPS and building a million of systems that are being deployed in the market, in automotive system, in medical system, in industrial system. So for systems that from Mobileye, from Microchip, and many other customers. So we know how to build the package. We build a package that provides safety element out of context that speed up between 6 to 9 months in SoC safety qualification. We have been reviewed by major OEMs already and got a good grade and good feedback about our safety architecture. And we bring in this knowledge and this know-how to the RISC-V ecosystem. And we see other companies following us and introducing their solution as well. And we really happy with this kind of growth of RISC-V dominant in the automotive ecosystem. So this slide is just here to show some of the elements. I'm not going to go into details. If you want to learn more about it, come to talk to us and see. But this is a proven technology that it's been proven in silicon. So to summarize what we presented today, we took our knowledge about microarchitecture, how to build a complex system, a thing that took us tens of years to learn and optimize to the different applications in the market. And we took this knowledge and we bring it to the RISC-V ecosystem. And RISC-V actually boosts this adoption because it enables us to accelerate innovation. The cost of companies to choose our solution supporting RISC-V is much easier for them and much less riskier because of the RISC-V ecosystem, because of the RISC-V solution. So we can see software support from Android and hopefully other software support coming forward, AutoSAR as well. So everybody is working together as a community to support this. And we are taking our knowledge and our thing and actually helping both for MIPS and the ecosystem to boost up and to build the capability. So we are presenting this week in the Embedded World in the booth here, and I'm open for questions and for any follow-up that you might have. Thank you.